Hi, it's Mark Maney here with the second in a series of videos outlining how to sketch exponential functions. Now, just to recap, if you haven't seen the first video, an exponential function is one that climbs this way when we deal with what's called exponential growth. The function itself increases at a constant rate rather than a constant amount. In its most basic form, it can be written in this form with the dependent variable and the independent variable on either sides of the equation. Note here that the independent variable, the x value, is actually listed as the exponent or part of the exponent or index of our equation. A constitutes the base and typically takes the value of some number. There's a few important points that you need to locate when you sketch these graphs. The first is the asymptote. You can see that the asymptote typically is marked in by a dashed line, and initially, on the most basic form of the equation, that asymptote is located on the x-axis. Asymptote's important because our graph will actually approach the asymptote but never ever touch it. You do need to locate 2 points on your graph in order to place it in the correct part of the xy coordinate plane. And typically, points of interest would be the Y-intercept, and if it exists, the X Intercept. Now notice here we've got the asymptote falling along the x-axis, so there will be no X Intercept. In which case, we need to ensure that we calculate a second point and mark that in, and I've done that here. To sketch the graph, we sketch with a nice smooth sweeping curve, making sure that it passes through the 2 points we've located and approaches but doesn't touch the asymptote. Let's look at some examples and see how they work. So here we've got an example where clearly we can see that we've got an exponential form, so it'll take that sweeping growth curve. But this time we've actually got a displacement, a vertical translation downwards. So our graph and the asymptote that I pointed out before will actually shift down 2 units. So where we'd previously have marked the asymptote along the x-axis, now we mark it in as that dashed line at a point 2 units down. So I'll place that in as -2. And we mark the value of that as y is -2, so that it becomes our equation of the asymptote. Okay. The other things we need to do is locate both the y and the x-intercept, so we'll work about doing it now. Y-intercept is always found when x equals 0. Seem to have paused there. My apologies for this. So the y-intercept is found when x equals 0. So we substitute in for 0 in place of the x. 4 to the power of 0 is 1. Take 2. And we see here that our y-intercept is at -1. And that can be marked in here. Okay, at -1. Notice also, typically speaking in our most basic form, where there is no translation, vertical translation of the graph, our graph, our sketch, typically will pass through the point y equals 1 on the y-axis. Now that's, of course, if there is no vertical translation, or later on we will see if there's no horizontal translation, or in some instances a dilation. So there's a few reasons why that value might change from its standard one, this one being one example of them. Okay, we need to find a second point. Because we're dealing with a growth curve, so as we're going to go along here, you can see that in fact at this instance we will be cutting the x-axis, so it's a good idea to actually locate that. So we'll find the x-intercept by letting y equal 0. And substituting this time for 0 in place of y. And we will solve now for x, progressively backtracking in order to get x by itself. So the first thing I'll do is actually take this 2 over the other side. It's being subtracted here, so we'll add it. So that becomes +2 equals 4 to the power x. Now, in the same way in maths, that to get rid of the -2, we apply the inverse operation, in this instance adding 2. What we'll do is we'll apply an inverse operation here. So where we've got x raised to the power, the inverse operation of that is taking the log. of that. And that will then bring the x down from the indice form into the standard place, and we can rewrite the 4 and the 2 as log 2 to the base 4. Now, I've previously referred to this as the base, and the base belongs here. As you say this out loud, we refer to the base last, so it's log 2 to the base 4. Okay, your calculators will actually help you determine the value of that, and having determined the value, you can actually place that over here. Now, if you don't have a calculator, or if it's a calculator-free exam, you can just place that value there as an exact value. Okay, that is quite okay. And then that becomes a little point on there. It is, of course, quite reassuring if you have it in your calculator to see what the number is, because it's a bit hard to conceptualize the actual size of that, but it's approximately 0.5-ish. Okay, we've got our 2 points, and I've already marked the curve in there, approaching but not cutting our asymptote, and that is how we might sketch one of those. Now, I will briefly sketch a third example to see if we can start consolidating our understanding of what's going on there. So here, something slightly different. Our base now is 3. But in this instance, what we've got is a negative indice. Just wait for that to come back into focus. My apologies again. So the negative indice up here, the negative in front of that, indicates that instead of exponential growth, we're actually going to have exponential decay. And that is, we will start large and we will get progressively smaller at a constant rate. So examples of this might be depreciation of a car. It might be marked down at, say, 25% every year. So it's 25% of what we call its residual value. So if it costs $50,000 to purchase it, after 12 months, it might be worth $37,500. That is a loss of 25% of its original cost price. And then after another 12 months, we reduce it again by 25%. So not by a constant amount, but by a constant rate. And you'll see this sort of curve occurring. Cooling of liquids and solids operates the same way. Okay, let's see if that'll focus again. Rightio. So moving along here, I'm expecting the curve to go like this, but let's just have a look. We'll look and identify the asymptote firstly. I'll sketch my axes. Now you'll notice here that there is no additional subtraction. One more time, and if it doesn't work, I'll edit this video. So there is no additional subtraction of the d value here, so that's your vertical displacement or translation. So that means our asymptote remains as it typically does on the x-axis. Okay, and I'll mark it in there. There's my x-axis, and I'll mark it in. My asymptote equation is y equals 0, just representing the dashed line. Next, to find the y-intercept, and we will have x equals 0 to allow us to do that. Now, 3 to the negative 2, if you recall your index laws, 3 to the negative 2 is exactly the same, pardon me, it's 1 on 3 squared, which is the same as 1 on 9, which is approximately equal to 0.111 recurring. Okay, so we can mark that in as our intercept here as just 1 on 9 or 0.1 recurring. Okay, there's a preference for exact values there. I know, or I'm expecting, that that curve will move and sweep downwards and approach, passing through the y-intercept we've just located, and approach the asymptote. Of course, it won't cut that asymptote, which means we have no x-intercept. So we've got to go and find a second point instead. And the choice of that, and I'll just label it here, the choice of that second point, often I encourage people to use the value 1. Okay, it's often we use one for ease. But if we think carefully about what might be easiest when we've got this value in here, perhaps the easiest x value that we can take in this instance might be -2, because the result of that would be have -2 plus 2, and that whole thing equating to 0. So I'm going to, with a bit of forethought, choose a value of -2 there. And that would mean I'll have 3 to the value of -0. Of course, there is no such thing as -0, it is just 0. So 3 to the power 0, which is 1. And that gives me a coordinate pair as -2 and 1. So we come over here as -2, and we go up here to 1. And you can see, in fact, that by locating our point here and our y-intercept, we are going to have that swoop coming down, or that sweep coming down, which I'll endeavour to try and draw now. Okay, heading down, not terribly successfully, I'm afraid, but heading down and approaching that asymptote. And that's drawing that particular graph. Okay, so just a reminder, locate the asymptote, locate the y-intercept, and if it's available, locate the x-intercept too. But in the absence of an x-intercept, locate some second point. Okay, thank you again for listening. Hope it's helped.